Okay, this is question, question number 6, part B. The diagram in Fig 6.2 represents wave on the surface of the water in a ripple. The waves are traveling from deep water across a boundary into shallow water. So now here the waves are moving from deep to shallow water. So you can see this one. Okay, before doing this question, let's do, okay, this is also same. Yeah, this question. Yes, this one. Look at this. Okay, this is also a little bit tricky. First, let me show you some easy question. Then we will move to the harder question. Yes, look at this question. This is May June 1531. Question number 6. A water in a tank travel from a region where the speed of the wave is faster into a region where it is slower. So, faster, where is the speed faster? So, where is the speed slower? First, we should know this. The speed is frequency is a wavelength. So, see this one. They are saying only the speed is faster. So, where the speed is faster? The speed is faster in deep. The speed is faster in deep water, in the deep region, okay, in the deep water, speed will be faster. Wavelength will increase. And what about the frequency? Frequency will be same for both. Again, I'm repeating, in the deep water, speed will be faster, wavelength will be increases, and frequency will be same. But in shallow water is opposite. Speed decrease, wavelength decrease, frequency is same everywhere. It decrease, this also decrease. So how you will draw this one? So suppose the incident ray is coming like this. Okay, the incident ray is coming like this. So you will stretch it so that it touch the boundary. This is the incident ray. The first thing what you will draw, the incident ray. This is the rule, R and Rn. R is, this is the incident. The second will be normal ray. So normal ray is, it's 90 degree to the boundary. So it lies 90 degree with the boundary. So 90 degree. Now the thing is, you have to know is when it cross the boundary, so if it is from deep to shallow, the refracted ray, what will happen to the refracted ray? If it is from shallow to deep, it will go away from normal ray like this. If it is from deep to shallow, it will be closer to the normal ray. Again, I am repeating, if it is from deep to shallow, it will go away from normal ray. And if it is from shallow to normal, if it is from shallow to normal, it will go away from normal ray. If it is from deep to shallow, it will be closer to the normal ray. So it is from deep to shallow, so it will be closer. So now how you will draw the refracted ray? How you will draw the wave? The wave will it will decrease, wavelength will decrease. It will be like this. This will become like this. This will be like this. so it will decrease. Okay, the space will decrease. Okay, and you must check this should be 90 degree with this, 90 degree with the refracted ray. And you can see the space decrease compared to this. So again I am repeating, when it is moving from deep to shallow, the refracted ray, sorry I don't want to move it, the refracted ray will be closer, like this it will be closer. See again I'm doing, it will be closer to the normal ray. This is the normal ray. Okay, so if it is shallow, then only thing is it will be away from normal ray. Again I am repeating, if it is from deep to shallow, it will be closer. If it is from shallow to deep, it will move away from normal ray. This is the normal ray. And this thing will draw perpendicular to the refracted ray. And you must keep in mind, when it moves from deep to shallow, the wavelength decreases in, okay, speed also decreases. So distance between two waves also decreases. You can see distance is less. So look at this question, this one. It is moving from shallow to deep. Again, it is moving from what? Shallow to deep, opposite. This is May, June 16. So, as I told you, see here, when it is moving from shallow to deep, it's moving from shallow to deep, right? So you will draw what? One normal ray. When it touches the boundary line, this is the boundary line. Okay, this is the boundary line. You will draw what? One normal ray, like this. The green one is normal ray. Then as it is moving from deep to shallow to deep, the refracted ray will move away from the normal ray. It will move away like this. This is the normal ray. It is going far away from the normal ray. It is going far away from the normal ray. So if it was from deep to shallow, the refracted ray will be closer to the normal ray, like this. So as it is going from deep to shallow to deep, that's why refracted ray is going away from the normal ray. So how you will draw the new wave? So So you will draw your new wave perpendicular to the refracted ray. What? Perpendicular to the refracted ray, like this, perpendicular 90 degree. Suppose this is your incident, so it should be perpendicular to the refracted ray. So look at this question. They are saying, this is May, June 1941. They are saying some wave front is going from air to solid. So if it is going from air to solid, from less dense medium to more dense medium, what happened? What happened to the wave? So when it moves from less dense to more dense, the first thing is like, angle move toward the normal ray. Okay, they are asking what are the changes to the wavefront. Okay, so the change is all the wavefronts will not hit all together. All the wavefront will not hit the solid at once. You can write all together. The second point you can write is the angle of wavefront changes at different parts of the wavefront, delayed by different amount. The first one you write, all the wavefronts will not hit together. The second point you can write is angle of the wavefronts will change. Angle of the wavefront will change at different part of the wavefront, delayed by the different amount of time. Okay, this one. Here they are saying this is region 1, region A, region B. By seeing the diagram, you can easily understand it moved from shallow to deeper. By looking at the wave, see the wave distance between two waves. When it moves to region A, distance between two waves increases. It increases, right? So increases when the distance increases when it moves faster. When it moves faster, the wavelength will be greater. The wavelength will decrease. Okay, so when it moves from shallow to deeper, the wavelength decreases. So they are saying to name the process that is, and they are asking such as the changes, when it moves from A to B, what are the changes? Wavelength increases, it move faster. Wave move faster, it means what? Wave move faster, and wave move slower in region A. Anything you can write, any point you can write. So see here, there is one more question. This is, you should read the question carefully. This is May June 20 question, paper 4-2, question number 5. Shows a crest of wave approaching a barrier where the wave is reflected. They are asking about reflection, not refraction. So you see, this is the barrier. So when it is reflected, you can say this one is reflected. So you will draw the normal ray like this, and you will draw the reflected ray. And this angle, and this angle should be same. This angle and this angle should be same. Okay? This angle and this angle should be same. As you know, in reflection, angle of incidence is equal to an angle of reflection. Okay, so you draw the reflected ray of all the wave. This wave, this, or this. Okay. So this also same, they are asking about reflection. So same thing you will do, but this is, and that one was coming from other side, this is coming from, the incident ray are coming from this side. So the incident ray are coming from this side, so you will draw the reflected ray this side. This is coming from this side, draw it that side. This is coming from this side, draw it this side. Okay, this one you can say it is moving from deep to shallow. So So if it's moved from deep to shallow, what I said to you, this thing, it will move closer to the normal ray. It will move closer to the normal ray. So draw the wavelength. So see here, draw the wavelength perpendicular to the refracted ray. Let me show you this. Okay, the file is stuck, it's not opening.